So if I see in reality, it's actually way complicated. So it's actually about graphs and linear algebra and stuff. And like if I were to entertain you guys for 5 more minutes, if you guys don't mind that, it's about let's just use Desmos. I think that would make sense for graphs. Yeah, just give me the Suraj is just rolling in the chat, whatever. Okay, so imagine we have certain points. Can we do points in Desmos? Please tell me, can we do points? A equals 1 comma 2. Okay, we can do points. That's fine. Let's label them. B equals question. Can we do points without labeling? Yes, we can. Thank you. Okay. So let's say that we have another point. Let's say we have uh, a few other points here and there. And okay, and let's just okay. So if I were to ask you, what is the value or what are you expecting for 10? If I were to ask you that, hey, 10, what are we expecting for 10? Okay, so imagine these are the different prices. Imagine the x-axis over here. Let's just take a screenshot. I think we should be fine if we take a screenshot over here. If Desmos doesn't freak out on us. So let's just take a screenshot of this and let's just go to Xcolor Draw. And as I said, steal if you can, no need to draw it yourself. Okay, so imagine we have these different points. Okay, now if I were to ask you what will be the output, okay, if I were to ask you what will be the output of, let's say, this point, like if I were to put 10 as a value. So just to clarify, the bottom line is what we call an independent. If I misspell it, please just excuse that. Independent variable. Okay, let's just increase the size of this. Okay, and we copy this because I do not want to make spelling mistakes. And this one is what we call the dependent variable. Okay, let's just make it sideways. Okay, so what it means is that the x-axis is responsible for y-axis. Okay, so imagine this is tax in India over time. So independent variable, that is time, and then the tax is increasing, which is a dependent variable, which is dependent on the x-axis. So the tax is kind of dependent on time and whatever. So once again, this is a 2D explanation. This graph could be 3D. This graph could be 4D, 5D. If there are 10 variables, if there are 10 independent variables and if there's like one dependent variable, this would be an 11D graph. But that's besides the point. Imagine one independent variable, one dependent variable. That's it. Now, if I were to ask you, what will be the value of 10? Could you guys tell me what will be the value of 10? Is it possible to tell me? Is it possible to like give a general idea? Would it be okay? Let's guess. Would the value of 10 be over here? Is it possible that the value of 10 could be over here? Or is it possible that the value of 10 could be over here? I'm horrible with drawing. Or is it possible that the value of 10 could be over here? Or is it possible the value of 10 could be over here? So imagine these are the 4 different points. So I'll just say this is A, this is point number B, this is point number C, this is point number D. Now just use chat. In the chat, just tell me, out of these 4 options, A, B, C, and D, what is the most likely value for our 10, like x-axis 10? What will be the point which is corresponding with the 10 x-axis? A, B, C, or D? What do you think would be the rough, like what is the most likely option is what I'm trying to ask. Hopefully that is making sense for you guys. The reason we can see, okay, that's fair. I don't know why Suraj would say C, but okay. So the reason we, our human brain can actually look at it and be like, okay, we are kind of understanding where the general trend is going towards, right? It's like I would imagine if I was in your place, I would imagine a line to be passing like this. Okay. I would imagine a line is trying to go like, in the middle from somewhere like this. And I would just try to make sure like, this line is like in the center between like, most of the points. What I'm trying to do is I'm trying to minimize the distance between this line, whatever line we have, and all of these different points. So you can see this is point number this. Let's just draw a few more lines. So this is the distance over here, and this is the distance over here. So what I'm trying to do is I'm just trying to minimize the distance this line has from all of these different points. Okay. Let's just do this. Oh, I think we did A 2 times. Yeah, that's fine. And I would try to create a line which would minimize all of these distances. Like, so this is 1, this is 2, this is 3, this is 4. Like, obviously, I'm considering all of these as well. So I have to make a line which is minimizing this. Now, if I actually go inside the mathematics of it, it's actually pretty simple. I would just try to create a very simple formula and just try to calculate the distance. And that would be what we call, let's just write the distance. So the total distance is actually, we try to calculate it with squares, but whatever. I can call it x1, then x2, and then dot dot dot, because there are 9 variables. I have x9, and all of them are actually squared. Okay, so we obviously find the square of them. Why do we find the square? It's a bit complicated, but this is the squared distance from the line. Okay, and our job is to minimize the distance. Okay, our job is to minimize the distance, and so this term is actually called the least square distance. Okay, we want to find the least square distance. We'll try to adjust the line here and there. We'll try to move it up and down. We'll try to adjust the angle of the line. We'll try to do all of this. Obviously, we know that the equation of the line is just mx plus c, right? So you're just trying to just change the equation. Okay, that's what I'm trying to do. Like this equation, I have to change the values of m, x, m and x in such a way, and obviously the c, that this distance becomes the lowest. How do I do that? Well, if you have ever learned differentiation and integration, all I need to do is I need to find the global minima for this function. And that's where differentiation comes along, and that's when a lot of fancy stuff happens. But this is what machine learning is. I'm trying to find the least, like this is my loss function at this moment. Okay, I'm trying to make this function go down. I want this value to be less. And that's what it means. If the value is less, then I can create this line. Okay, and wherever this line goes on 10, so this is where where my point would be, like somewhere over here, I guess. Okay, so that's where my answer would be, like, hey, that is what I'm predicting in future. Okay, this is how people use machine learning to predict stock prices. Okay, this is what it means. Okay, that is how linear regression works. And if you notice in the previous example that I did with dog and cat, and I told you guys that, hey, this has to go towards dog and this has to go towards cat, like the machine learning algorithm, there as well, we have a loss function and we are trying to reduce certain values. So like if I want the cat to go down, like if I want the percentage of cat to go down, I'm still using a loss function, which is just this graph, but in like what, 11D or 12D or whatever. So that this is what machine learning is, more or less. Okay, hopefully this made sense. This was a very, very, very rough explanation of what is linear regression, but yeah, this is what we call linear regression. This is the first step to machine learning algorithms.